We are all different. There is no such thing as a standard or run-of-the-mill human being, but we share the same human spirit.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Very sad news. Professor Stephen Hawking dies aged 76.
I suppose that's not old these days, but he was given 2 years to live when he was 22.
This is it. I watched yesterday, I caught up and was doing a bit of research on him, and I watched the Dara O'Brien documentary. Mm-hmm. Absolutely amazing. And yeah, I think he said that the reason he thinks he lived so long was because of science and because he just had that tenacity to keep learning and keep discovering. Incredible. What a life, Matt.
Yeah, I mean, I actually think if we're going to go into anything, that is his biggest legacy, is two things. One, what an inspiration he must be to people with disabilities. And two, that whole thing of if your life has purpose, you can literally put up with almost anything.
Absolutely.
I mean, it's possibly the most horrendous disease you can have, ALS, and he's kind of lived his life to the max. It almost lived his life really normally, telling jokes, getting married, having children, getting divorced, getting married again.
Travelling to Easter Island.
Yeah, travelling all over the world and meeting people and also being a great scientist. Oh. In America, when they do surveys and they say, name a scientist, pretty much the only scientist people can name, and I should imagine that's the same in this country as well, is Stephen Hawking. So, I mean, he's literally possibly the only famous scientist. There's a bit of a debate going on, and I fall slightly on the side of the debate that Hawking wasn't a genius. He was a very, very great scientist, but doesn't fall in the same category as, say, Newton or Einstein, because he didn't actually invent a whole new field of physics or
but in
cosmology.
Terms of contributing towards
his contribution, his contribution is massive. And in actual fact, we won't really know what his contribution is until someone finally cracks the quantum gravity nut, as it were. And then that might reveal, what he's, a lot of his work, whether it was on the right path or completely the wrong path.
Absolutely.
But whoever does that will be, I think will be considered a genius. So, I heard a lot of things like Roger Penrose, who's obviously a contemporary of Stephen Hawking's. I read his obituary in The Guardian, and it was pretty measured. Obviously, he was talking as a scientist. And I think in the scientific community, I think there's the feeling that Hawking was a bit overrated, but I think that's a little bit unfair. I just think they were maybe a little bit jealous of his fame. But I mean, how can you overrate someone that's overcome dreadful affliction and done a huge contribution to cosmology? Yes,
absolutely. Yeah, I mean, yeah, as you say, it sounds like jealousy. If you look at the awards he's won for his scientific work, the awards aren't, this is going to a scientist with a disability. Congratulations, this is going to a scientist.
Yeah. Oh, no, absolutely. But he's never won the Nobel Prize, and I think the reason being is if you're a theoretical physicist, you actually have to have the observation. And Hawking radiation, for example, is very, very hard to observe, because it's so pathetic. It'd be like trying to spot an LED on the surface of the sun. It's that kind of ludicrousness.
But Matt, how incredible is it that born on the 8th of January, 1942, exactly 300 years after the death of Galileo, and he died on March the 14th, 2018, on Albert Einstein's 139th birthday.
Yeah.
I mean, it feels like a circle's complete there, no?
It's a coincidence for sure, but I wonder how many coincidences you could have tried to extract from there. I think the 300 years after the death of Galileo, that's a really cool one, isn't it?
Yeah, it's really cool. Brilliant stuff.
Yeah. So Hawking went to Oxford University at the age of 17, but I think he found it a little bit boring when he first got there. He all found it a little bit too easy, and he wasn't challenged. He wasn't particularly social, so he didn't have many friends. And it was only when he became the cox of the boat, of the rowing club, that he kind of started to really come out of his shell. And he said he did something like 1,000 hours to do his undergraduate degree, 1,000 hours of work.
Wow.
And I should imagine, so in Oxford, that's obviously completely ridiculous. So he barely scraped through, and he needed a first if he wanted to go to Cambridge, which is what he really wanted to do. At his Viva, apparently, this is what he said. He says, "If you award me a first, I will go to Cambridge. If I receive a second, I shall stay in Oxford. So I expect you will give me a first." Because he thought
definitely wasn't shy, was he?
Well, no, I think he thought his lecturers were fed up with him because he was so lazy. But apparently, they were actually very, very impressed. Most of them realised that they were dealing with someone cleverer than themselves. So
absolutely.
Off he went to Cambridge, and he really wanted to study under the great Fred Hoyle, who was definitely one of Britain's most famous cosmologists at the time. But instead, he got a guy called Sharma, who is considered one of the fathers of modern cosmology, but he wasn't as famous at the time. And it was that period he got diagnosed with ALS. Went into a bit of depression, but then snapped out of it, and don't know how. Obviously, just the work, I suppose, overtook him, and this is where he first started to kind of look at the work of Roger Penrose and looked at his theory of space-time singularities, and that's what he wrote his PhD thesis on. And so he attained his PhD degree in Applied Mathematics Theoretical Physics in General Relativity and Cosmology in 1966. And his essay that he wrote during that degree was Singularities and Geometry of Space-Time, of which he shared top honours with Roger Penrose for the prestigious Adams Prize.
That was the first one.
Mm-hmm.
So in his work and collaboration with Penrose, Hawking extended the singularity theorem concepts first explored in his doctoral thesis.
So he actually started during that period to formulate the laws of black hole mechanics, and he noticed that it was a bit of an analogue of thermodynamics. But what really irritated him is that a guy called Jacob Bekenstein argued that it was literally thermodynamics, and Bekenstein was actually proved right eventually, and I believe Hawking's lost one of his infamous bets. And as I say, it turns out that Hawking's is a rubbish gambler. He shouldn't have done it. I think he loses most of his bets during this thing. And remember a couple of weeks ago, Harriet telling us about Kip Thorne's little note on the side of outside of his office with a bet that Hawking's has lost.
Well, in fact, Kip Thorne in this documentary said that he'd never met anybody as stubborn as Stephen Hawking's.
Yeah.
And it's just, I mean, you just have to have that, don't you? If you look at his life. Incredible.
Yeah, obviously, people like Roger Penrose, Kip Thorne, and lots of others of that generation. It must have been brilliant having those great minds all clashing and going, no, this is it, this is it. He actually went to Moscow, something that I wouldn't recommend right now, and met a couple of Russian physicists, Zeldovich and Starobinsky, whose work on black holes suggested that rotating black holes can emit particles. So it wasn't Hawking's wasn't the first person to kind of spot this, but Hawking then realised, much to his annoyance, that Bekenstein was right, that black holes could get smaller, and Bekenstein's reasoning about entropy was in fact correct. But this spurred Hawking on to do arguably his crowning achievement, and that crowning achievement is Hawking radiation. And obviously we've mentioned this quite a lot, and annoyingly, I cut it out of our chat about black holes last week because the black hole episode got too long. So I cut out a big chunk of Hawking radiation. Well, we were both
gutted, weren't we? Because we left his bit out.
We had no idea what was about to happen.
However, we're going to cover it.
Well, it means that we can cover it slightly better because in the meantime, I've read up quite a bit about it, and One of my favourite videos, by the way, if you really want to know about, is Matt O'Dowd's PBS Space Time.
One of our favourites. He's been melting my head for many a year now.
Yeah. So the popular explanation of Hawking radiation, and this is how black holes leak their energy into space, is imagine space not as made of particles, but made of quantum fields. Now, these quantum fields are things like the magnetic field and things like that, or the Higgs boson field, for example. And every single particle is related to a field of some sort, which you can imagine as a kind of rubber sheet that's wobbling in, and they wobble. They're kind of fuzzy and sort of foamy, and particles come out of kind of vibrations on these quantum fields. So sometimes you get these virtual particles that spontaneously appear, and they borrow energy from the vacuum energy, and they borrow this huge amount of energy. You get a virtual antiparticle and a virtual normal particle, antimatter and matter, and then they quickly smash back into each other and return the energy back to the vacuum.
Right.
But the simplest explanation of Hawking's radiation is that if this happens at the event horizon, you might get a virtual particle that falls into the black hole and the other one that manages to escape it.
Got it.
Thus, the black hole is paying the price for this energy that wasn't returned to the vacuum, and so eventually the black hole will evaporate off. And the maths of this means that the bigger the black hole, it radiates excruciatingly slowly, and they look cold. But as they get smaller and smaller and smaller, they actually radiate more and more and more and more. So a very small black hole actually gives off a lot of this Hawking radiation and actually would glow. And when just at the end, it becomes extremely hot and would eventually explode. And we've actually talked about this before on one of our earlier episodes about interstellar travel, and it's the Kergel-Blitz drive.
Hope you'll remember.
Yeah. So that antimatter matter thing falling into a black hole is a bit of a fudge. So do you want me to go through roughly what the maths is here, Jamie?
Well, I'd quite like that, Matt. It's quite weird, isn't it? The thought of a black hole evaporating. It just sounds like something that a little bit of water on your window does.
Yeah, Stephen Hawking kind of used it as a really, really fantastic metaphor about life and depression, didn't he?
He did.
That quote where it's essentially, if you feel as though you're in a black hole, then eventually even that will go. You know, the most terrifying thing in the universe, and it eventually evaporates away.
And therefore, if you find yourself in a black place, in a dark place, then don't worry, because you can escape too. Incredible.
Amazing. So roughly, Hawking radiation, in terms of the maths, and it's the maths, that the incredible thing that Stephen Hawking did, and it was the first time anyone had attempted it, really, or managed to achieve it. That lots of people attempted it, but Hawking had managed to achieve combining general relativity with quantum mechanics, even though he used a bit of a fudge to do it. So he drew a single space-time path going at the speed of light from the distant past to the distant future of the universe, and then imagined a black hole appearing on that path. And what happens there is that the black hole then disturbs the fields, all these quantum fields of this space-time path that he's drawn. And then he looks at the fluctuations and vibrations on these quantum fields. And on one side of the black hole, in the past, it's just virtual particles coming in and out of existence, like we discussed. But on the other side, they seem to appear to become real particles. And to understand what was going on there, he had to try and fudge the theory of quantum gravity. And he used a thing called the Bogoliubov-Valentin transformation.
Rolls off the tongue.
which was actually developed for something completely different, a Nobel Prize winning Bardeen-Cooper-Schrieffer theory. So he managed to calculate the quantum theory in space-time using that crazy bit of maths. And then he discovered that escaping particles have wavelengths about as large as the event horizon radius.
Got it. Wow.
And furthermore, even more incredibly, it should look like a heat glow. It's thermodynamic in nature, and it's proportional to the event horizon of the black hole. And this was an incredible result.
That's amazing.
It is amazing, and lots of other people have used different methods to get to this Hawking radiation, like particles quantum tunneling from inside the event horizon and out again. Have you ever heard of the information paradox?
I haven't.
Information, the conservation of information, is the big deal. That's in quantum mechanics. It's an absolute tenet. So in 1981, Hawking was saying that information in a black hole is irretrievably lost when a black hole evaporates, and that actually meant that it's his Hawking radiation is violating an absolute central tenet of quantum mechanics. And that debate led to the holographic principle proposed by Gerard de Hooft and another great physicist, Leonard Susskind. And they had lots of arguments with Hawking. Standard. And I think they are another pair of people who want to bet against Hawking.
I was going to say, did he lose more money?
Yes. No, I think there's lots of times where I don't think it's money, it's things like encyclopedias and stuff that he kind of loses.
That's such a Cambridge way of betting, isn't it?
Yeah. So that kind of made him an absolute, sensation in physics. He was truly on the science map at that point.
Rightly so.
Hawking radiation.
Incredible.
He worked with Kip Thorne.
Down at Caltech?
Yeah, down at Caltech. And he bet Kip Thorne that the X-ray source of Cygnus X1 was a black hole. And Hawking actually said it wasn't, and Kip Thorne said it was. And then Hawking acknowledged that he'd lost the bet.
Right.
One other really massive thing of note is a thing called...
You're not going to say the Hartle-Hawking state of wave function of the universe, are you?
I am.
Oh
he tried to get the wave function of the universe.
It's no easy thing.
No, and I think it was to try and figure out how the universe started using Feynman's path integrals. And it was to try and state that the universe has no beginning, but it's not a steady state universe either. And I think the analogy is, imagine a globe where you go to the North Pole and then you think, well, let's go further north, and it doesn't make any sense, but it doesn't mean that you can't. See what I mean?
Yeah, I gotcha.
It's kind of an analogy to that. Here's another bet that I think's amazing.
Go on.
I mean, bear in mind that Higgs is still alive, and he won the Nobel Prize. Peter Higgs, in 1964, proposed the existence of a thing called the Higgs field, which gave particles their mass. And Hawking completely disagreed. And Hawking was pretty critical of Higgs' work, and Higgs then fought back and was pretty, this is what he said. So Peter Higgs said, celebrity status gives him instant credibility that others do not have.
Ooh, okay.
But so Hawking was proved wrong. So the Large Hadron Collider meant that the Higgs field was a reality because they found the Higgs particle. So Hawking quickly conceded that he'd lost the bet. This is my favourite experiment that he ever did. In 2009, on 28th of June, Hawking invited everyone to a party, and there was hors d'oeuvres and iced champagne, but he only publicised the party after it was over, so that only time travellers would know to attend. But nobody showed up. Thus proving you can't go back in time.
No, it's impossible because, as you know, Matt, nobody gives up hors d'oeuvres and iced champagne. It just doesn't happen.
No, so there we go. So Hawkins has proved you can't go back in time.
And that actually really upset Dara in the documentary because he said that it disproves the Terminator films.
Oh, no.
Which he was gutted about.
What, does Dara think that Terminator is a documentary?
Yeah, I think he thought it's just a slice of reality.
The Irish. So last thing, Hawking's, of course. Hawking. I love the fact that lots of people spell it Hawking's. Hawking viewed space flight and the colonisation of space as necessary for the future of humanity.
He absolutely did.
He also warned about actually contacting aliens as well, because he thought that they'd be dangerous. But then he also backed the Breakthrough Initiative. So he's full of inconsistencies sometimes, I think.
He is, but one of the great things that he was saying was that he's pretty sure that, in the next kind of century that we are on this finite planet. Is it going to be an asteroid, Matt? Is it going to be a nuclear war? Is it going to be a deadly disease? And so he's a massive advocate that we should be going to Mars,
Getting out there, as is our guest today.
Oh, yes. Seamless link.
So before we go into our guest interview,
yes,
do you want to hear my limerick that I wrote about Stephen Hawking?
Oh, yes, please.
On the way to work, I thought, I'm going to write a little limerick about Stephen Hawking.
Go for it.
Hear it. There was an old man called Hawking who had an unusual way of talking, and with an equation found a unique radiation and roamed the cosmos without even walking.
That is genius, Matt.
Listeners, if you come up with any Stephen Hawking limericks, send them in.
Absolutely, please do.
So it's time for our interview. Who have we got, Jamie? This is one of your favourites, isn't it? You were like a little excited puppy running around in his basket.
I'm still excited. It's absolutely brilliant. And what a guy. He's called Mitch Hunter-Scullion, quite the name. And he's just one of my favourite people that we've had on. I thought he was brilliant. I thought he had a great outlook and really super interesting. Matt, I don't want to say it, but I'm going to. I think he might be the Scottish Musk.
Maybe he is the Scottish Musk.
He's young enough. I think he's going to come through the ranks of the Asteroid Mining Corporation, and I think he's going to get to the top. Got a good feeling about Mitch.
There's only 4 countries doing asteroid mining and thinking about it seriously, and he's managed to put the UK as one of those.
It's putting them on the map.
As we shall hear, écoutez.
Roll it.
The Interplanetary Podcast, putting the ace back into space.
Ladies and gentlemen, we are joined by CEO and founder of the Asteroid Mining Corporation. It is Mitch Hunter-Scullion. How are you, Mitch?
I'm very well, thank you. How are you?
Thanks for joining us. Yeah, we're good. As I mentioned before we pressed record, I've been slightly obsessing over, as Matthew will confirm, over mining asteroids for quite a while now. And I want you to start off by telling us a bit about your background and how this all came about.
So basically my background, believe it or not, is in international relations and history. So I did an undergraduate degree in international relations and I graduated in 2016. But
Right.
I actually did my dissertation on asteroid mining because I was quite interested by it. And during my research for it, I found out that there wasn't any British asteroid mining companies, and I thought, that's a weird coincidence. So it was round about that time I was sort of looking into it a bit more, and I thought, well, what about the name Asteroid Mining Corporation? That would be a good name to sort of hold on to for the future. So I then trademarked the name, and from there, sort of, then essentially it was a case of sort of trademark the name, move on, and then we developed a roadmap to the utilisation of asteroid resources, started building up a team, and now just under 2 years later, we're now at the point where we're sort of ready to start going public with our plans for our first satellite, the Asteroid Prospecting Satellite 1, and we're engaging a bit more publicly now with our plans and what we're up to. So it's been an exciting 2 years. It's not been an easy 2 years, but it's been exciting.
I can imagine.
I love the idea of a British company being involved in the third industrial revolution. I thought that's a nice touch on your website. What missions do you have planned? You mentioned the first one, but is there a kind of long list of missions that you've got planned, and how far along are they?
Well, to be fair, we're only at the very beginning stages of our first mission, but we've got our roadmap, which is essentially from today, taking us all the way up to when we're mining asteroids and potentially beyond. So the first mission is the Asteroid Prospecting Satellite 1, APS-1 we call it. So APS-1 is sort of ideally going to be launched in late 2020, and that's going to do a spectroscopic scan of all 10,000 near-Earth asteroids that we know of. And with that, we'll be able to determine the composition, and sort of once we have the compositional data for these asteroids, we can then work out a value, and that will sort of feed into sort of selecting mining candidates in the future. Beyond that, we are looking potentially at an APS-2, which would be going to an actual asteroid and doing a close-up survey of an asteroid with a CubeSat. That's probably going to be about 2023 at the earliest, so that's a fair couple of years away at the minute. But it's in sort of the early planning stages for that. Yep. And then beyond that, we'd be looking at sort of the Asteroid Mining Probe. So Asteroid Mining Probe 1, we call it. We like sort of straight to the point names. Yeah. Asteroid Mining Probe
Makes
1
it
would
easy.
be going. Oh, of course. Yeah, Asteroid Mining Probe 1 was probably not going to be launched until at the earliest 2028, but we believe by 2030 that sort of the first asteroid mining missions will be sort of operational by that stage. So Asteroid Mining Probe 1 will take all the data and all the experience that has been generated over the past the next 10 years of missions, and from that will pick the ideal asteroid mining candidate, and from there we will then sort of send up a probe, we say a small sample, we're still talking in sort of the level of about 10 tons, but compared to NASA's OSIRIS-REx, which is covering a few kilograms, is hugely ambitious. But with the sort of the increase in launch capabilities with Falcon Heavy and sort of the BFR, there's all kinds of new possibilities for heavy machinery to be stuck up into orbit. So when we're sort of we're thinking Mitch, future forward.
Talking of technology, I mean, I understand that you're quite involved in the development of the technology itself. Is that right? Or are you completely outsourcing everything?
Well, we're developing our own payload, but we're using sort of commercial off-the-shelf parts for the satellite itself, because there's no point us developing our own satellite equipment when we can just purchase it from companies in the UK, sure. And then it just speeds up the development process, because essentially we're in a rush with our competitors now. So there's a big race between sort of the big space mining companies, and as one of the little space mining companies, we want to get into that race as quickly as possible.
I was about to say, I've got an oil baron friend who I had a drink with last night, and I was mentioning this interview that I had coming up, and I mentioned asteroid mining, and he was sort of saying, he was kind of very interested. Is now the time to invest in it? Is there a sort of new gold rush about to happen for asteroids, do you think?
I think within the next 5 years, you'll be seeing considerable development, because you have to remember it's not just the Asteroid Mining Corporation. There's Planetary Resources, there's Deep Space Industries, and between sort of those two companies alone, they have several hundred millions worth of funding. You've also got iSpace, which is a Japanese company that's looking to mine the moon. They have just received over $90 million in Series A funding. So space mining is now here. This is the time to start investing in it, to be honest, because it's not going anywhere, and the earlier you invest, the bigger the returns will be.
And actually, talking of returns, Mitch, just looking at your website, I mean, some of the stats are mind-blowing. I mean, you say here an asteroid 25 meters across could contain 30 tons of platinum, or around 750 million. But then when you go on to talk about a similar size, 2.5 to 3 kilometer in diameter, and both asteroids are M-type metallic asteroids, if they follow a similar composition to recover meteoritic samples, they contain at least 10,000 tons of gold worth approximately 300 billion, and also 100,000 tons of platinum worth approximately 2.5 trillion.
I mean, I should
these
put
numbers
sort of
are insane.
Disclaimer note in that one, though, and the fact that if we were to introduce 10,000 tons of gold and 100,000 tons of platinum into global supply, and all in one go, I should say, at least, then the price would just collapse.
I'm sure.
It's amazing when you're just looking at the volume. I mean, for people who don't know anything about the metals and the minerals on asteroids, can you give us a kind of brief overview of what people can expect from near-Earth asteroids?
Well, on near-Earth asteroids, they sort of essentially there's three main compositions of asteroids. So you've got your C-type asteroids, which are carbonaceous. So they're essentially sort of big lumps of carbon, got a bit of sort of water in the form of hydroxyl. What else would be in them? Sort of little, small sort of deposits of iron in the form of ore. So there's also stony silicaceous asteroids, which are essentially big rocks in space. It's probably the easiest way to describe them. So on board of them, you would have, for example, iron ore, platinum ore, a little bit of gold ore, but in the various concentrations that are not going to be as profitable as mining metallic asteroids, which are our focus. But compared to a carbonaceous asteroid, then you're going to be finding silicaceous asteroids containing slightly more water, and essentially water in the form of hydroxyl can be converted into hydrogen and oxygen. Hydrogen and oxygen being fantastic rocket fuels, and together water, which is the ingredient of life. So if you can have water in space, you can have a vastly increased human population in space, which is why I personally believe that asteroid mining is sort of the key to human expansion into space.
Yeah, I mean, that's the really interesting thing, isn't it? That now that we know that there's water up in the asteroid belt, that has changed everything in terms of the fuel and life support, hasn't it?
Oh yeah, completely. I mean, now that we know that essentially asteroids can be described as, what is it the Americans like to say, the gas stations of the solar system, then we can now use them to sort of as waypoints throughout sort of the inner solar system. So if you know that, and essentially this is one of the major parts of our project as well, is that we want to map out those sources of water so that we can then say for certain, just in the exact same way that early sort of explorers and pioneers used to chart rivers and look for sources of water 200, 300 years ago, we want to do the same with asteroids, just to say this asteroid contains, 10,000 tons of water that would be able to sustain sort of a spacecraft for, 200 days. And then having that knowledge of the resources that are sort of relatively nearby, sort of cosmic terms, will majorly feed into sort of deeper human exploration and expansion into the solar system.
And actually, Mitch, something that's really exciting is that because we're going to advocate you as a British asteroid mining company, it means we'll be able to call it the petrol station of the, I think we should get rid of this gas. I mean, too much American stuff going on.
I agree with you. It's the petrol stations of the solar system.
Exactly.
Yes.
Exactly.
So it's your little chef of the solar system.
This is it. Do you get a sweet afterwards? Oh, I used to love that little lollipop. Brilliant stuff. So, Mitch, what would you say your biggest challenges at the moment are?
Well, the main problem we have in the UK is actually a legal challenge, because technically, I mean, our early missions aren't that technically complex. I mean, sending up satellites obviously contains quite a lot of technical difficulty and sort of complexity and risk. But compared to actually going forward into sort of 10 years' time when we're mining asteroids, this is relatively straightforward because it's mostly using stuff that's already been used. But the main problem we have in the UK currently is the fact that there is no legal regulation for space mining currently. Countries like the USA and Luxembourg already have a codified set of regulations saying that space mining companies can go clear sources from asteroids or the moon, bring them back to Earth, and they gain ownership rights through the act of extracting that resource in a very similar way to if nobody owns the sea, but you can go launch out a line, catch a fish, and through the act of catching that fish, you own that fish. Essentially, it's the same process or thought process with asteroids. So I'm now lobbying the British government to adopt similar legislation to Luxembourg and the US so that Britain can now sort of rightfully take its place as a space mining nation, because we are, I think, one of only 4 countries in the world that has a space mining industry. So right. I really could use the UK government to catch up in this one.
Absolutely.
But Luxembourg has sort of states a quite strong claim as being sort of one of the major space mining nations. So if you want to do space mining in Europe, you go to Luxembourg.
Wow, okay. Why is that?
So they have a €200 million space mining development fund. They also have sort of a very welcoming regulatory environment. So essentially, they say that if you were to move to Luxembourg, you'll get funding, you'll have regulations, which mean you can legally do what you're sort of trying to do. And as well as that, looks like the Asteroid Mining Corporation will sort of look to expand to an office over there as well, as we look to become a multinational. So It's all sort of, they seem to be the place to be in Europe for it currently. But Japan, Asteroid mine asteroids, they want to mine the moon, and to be fair, mining the moon doesn't make them a direct competitor to us. So I'm quite enthusiastic about their plans and what they want to do, because I think they're sort of really going to do amazing things over the next 10, 15 years. And they've, just the fact that they raised $90 million in Series A funding is incredible. It's one of the biggest Series A raises in Japanese history, I believe. So even though they currently don't have the legal sort of framework, I've been talking to some colleagues over in Japan, and if Britain was to adopt sort of legislation, then Japan would probably be the next to follow. So there's quite a lot of sort of interest between Japan and Britain at the minute to try and sort of see how sort of the cards are going to fall with regards to the space mining industry. And that all comes down to Parliament coming down to sort of adopting legislation in support of the industry now. That's the major stumbling block at this stage.
Yeah, so when you saw Falcon Heavy launch, did you think, like us, that this is a brilliant opportunity for cheap, deep space exploration, because it's a private company that's opened that cheap door into deep space?
I think, well, personally, I think Elon Musk is one of the greatest visionaries of the early 21st century. So I strongly agree with you in the fact that Falcon Heavy is a game changer for private space companies. Essentially, sort of having that cheap, ready access to space is going to allow sort of new industries and sectors like space mining, like lunar exploration, all the things that sort of NASA and the European Space Agency and every other sort of space agency should have been doing for the past sort of 30, 40 years, but haven't really had the funding to do. Now that private money can sort of obviously do it cheaper and more efficiently and more regularly, I think this is now the period in history where we begin to see the change from sort of, I suppose you could call it sort of socialist space, where sort of it's government money and big, huge projects worth billions, to sort of private commercial space where you have small, plucky teams who working in very small budgets who are able to sort of do quite fantastic achievements with very, very limited resources. But at the end of the day, it's about being able to broaden up the amount of uses of space. So, I mean, space is massive. I don't need to tell that to you too. There is, if you think about it in a geographical sense, you sort of have to imagine the scope of it just expanding beyond the Earth for millions of miles in every direction. And then when you get to that sort of concept, you go, well, what about all the resources here? Just by the fact that we're able to have sort of low-cost access to deep space now, then we can start thinking about sort of the asteroids that are just beyond the Earth's sphere of influence. We can start thinking about sort of the Apollos and the Atens and all these sort of asteroid groups that currently are a little bit too expensive to get to. Within the next 5-10 years, they'll be quite cost-effective to get to, and that's going to be a massive game changer over the next sort of few short years, where we will see sort of, I believe, other space mining companies are going to arise in the next couple of years as well. So there's going to be a lot of competition.
It's odd, isn't it? I'd have expected Elon Musk to start talking about this, because he seems to have his finger in so many pies. It's quite amazing that he hasn't dipped into the asteroid mining thing. Or do you think that will change?
I'm amazed he hasn't already, but I think he's probably waiting to see sort of what comes of the early companies that get involved in it before he sort of starts pushing serious money towards it. Because, I mean, SpaceX would be a perfect asteroid mining company, and the fact that they actually have their own rockets.
Especially with the boring company as well. They've got the drills.
The drills, they've got the drills and the rockets. It seems to be sort of, if he's not announced it, I wouldn't be surprised in the next 5 years if Elon Musk comes out and says he's wanting to mine asteroids as well.
Another really interesting thing looking at your site was your objectives. Now, your objective number 6 was talking about construction of space habitat with gravity. Can you talk us a little bit more about that and what that might entail?
So essentially, I mean, even going on sort of a 25-metre diameter asteroid, there's only that a 25-metre diameter asteroid would weigh approximately 10,000 tonnes, of which only 100 tonnes would actually be sent back to Earth, because that's the platinum group metals, the golds, a couple of rare earths, whatever. And the 9,900 tonnes that are remaining would mostly be iron and nickel. So iron and nickel, the two ingredients of steel. So essentially, you could be looking at being able to manufacture sizable habitats in space with sort of quite small asteroids. So it's sort of waiting for sort of additive manufacturing to catch up. But essentially, in the near future, it doesn't seem, in the next 20 years, impossible to imagine that we will be mining asteroids and using the resources, or the leftover resources, I should say, to build habitats in space. So we've come up with this idea that we call Pi-1K, which is essentially a 1 kilometre diameter disk, and then that will spin. And with this spin, essentially, you'll be able to have gravity in space. So all the negative health impact of zero gravity will be avoided, and you'll be able to sort of sustain quite sizable populations in space with using sort of equipment like this. So essentially, it's going back to sort of the old torus spheres and essentially O'Neill cylinders of the 70s. But the problem that they had is that sort of they were too far into the past, where sort of things like asteroid mining didn't seem to be commercially viable at the time. Whereas now that sort of the resources seem to be a bit more viable to access, and we have to do something with the leftovers from the mining process, it seems to be sort of just common sense that we'd start building infrastructure and habitats in space. And that's where I find my personal deep interest in asteroid mining comes from, and the fact that it will seem to be the way that we actually start pushing thousands of humans into space. Currently we have 6 people in the International Space Station. We should have 6,000 in orbit. We should have 6 million people in space. We sort of set an ambitious aim, admittedly, of 1,000 people living in space by 2040. And we want that to be 10,000 by 2050, because we have a limited space on this planet and we have an ever-growing population.
That's really interesting that you mentioned about the health benefits of having gravity. I mean, we were talking the other day about the fact that obviously, just the effect on your bones being on the space station. I mean, if you're talking about being on this, on another planet for years, then that's going to be something that is seriously going to affect your health. And people don't really know the effects of it yet. So that's really interesting.
People in 20, 30 years on Mars, for example, I think that's going to have to be a one-way trip, because I don't believe that their bone density, unless they're willing to exercise incredibly rigorously every day to keep up to sort of Earth standards, I think evolution is going to naturally take effect, and essentially you're going to be looking at a new evolutionary phase in history where we go from being Homo sapiens to, as I like to call it, Homo Solaris, which is the humans of the solar system. So we'll all share the same DNA, but our environmental conditions will sort of cause different sort of evolutionary changes. So I think that's a very exciting prospect for the next 100, 200 years. Yeah, I just hope I live long enough to see it happen.
No, absolutely. I think it's a really interesting point that you've kind of made, is that maybe with the discussion of should we be going to Mars or should we be going to the moon, maybe really we should be talking about should we be going to the asteroids and actually setting up an economy in outer space that would support an obvious habitation of Mars and the moon. But until we do that, let's get an economy going so that it's much easier to do. Would you agree with that?
Well, yeah. I mean, the way that sort of people tend to look at the moon and Mars currently is the same way that we look at Antarctica. And the fact that it's very sort of pristine, it's the wilderness, and you do a lot of scientific research, but no one makes money in Antarctica. And I don't think, I believe on Earth, then that's a perfectly viable model because there's a biosphere and it's a very delicate, fragile biosphere. But in space, I don't believe that to be the case because it's a vacuum. There's no air, there's no pollution, and there's no environmental damage. Yeah, I suppose when you have 1 billion people living in the moon, you could probably have a different argument, but that's for about 100 years from now, that argument. But essentially, when you're looking at sort of the economy in space, I believe that sort of the economy is essentially, you can compare it to sort of the early 1800s. So in America, the railway, the infrastructure went in, and once sort of you had your early pioneers go out, explore these places like Lewis and Clark, and then after Lewis and Clark mapped out the area, the railways went in, and following the railways was humanity. So you had people settling along the railway, towns sprung up, and before you knew it, sort of most of the US had been settled. So it's going to, I believe, follow a similar sort of pattern to that, in the fact that you have to have an economy first. So we've reached the early exploration stage. That's already passed now. So it's a case of trying to get past the exploration stage into sort of the infrastructure being established. And once the infrastructure and the economy has been established, then we're potentially looking at humanity following, and that's sort of the real exciting bit. But I do not believe that humanity can go before the infrastructure does, because it just won't be sustainable.
That's a really nice and kind of romantic way of looking at it. I love that. Actually, one of the things that I wasn't aware of that I found out was, am I right in thinking, Mitch, that the metals on an asteroid are actually opposite to the metals on Earth in that they're on the outside of the asteroid, therefore easier to mine. They're not in the centre. Is that right?
Well, essentially, metallic asteroids are, this is a terrible term, but bear with me, monolithic globules of material. Essentially, a monolithic globule is that they're all just sort of one big sort of chunk of material. So unlike the Earth, where sort of the heavy, dense metals like platinum group metals sunk into sort of the deep core and the crust, then in the early planetary formation, on asteroids, they're not big enough for sort of that sort of gravitational pull to affect the weight of the metals. So it means that sort of things like platinum will be able to be found on the outsides of asteroids.
Right.
And that makes our job as asteroid miners considerably easier than sort of having to drill through sort of a couple of 100 metres of asteroid to get to the stuff we want. So that means that we can just go down, send probes, extract the material that we're after, and then sort of leave the asteroids for future exploration. It's a very beneficial to us that sort of it seems to be that metals are on the outside, because essentially it all comes down to sort of planetary science and the early formation of the solar system. But sort of the way that the asteroids were formed means that sort of the metal is sort of tends to, and the spin notation means that the metal is always on the outside. So it makes our job just a little bit easier.
Yeah. That's amazing.
Have you seen the TV series The Expanse, by the way?
Oh, of course I have. how could I not have? One of my favourite comments in that BBC video was that someone said, "and so the belt was born." So I thought that was quite nice. I might have indirectly caused the expanse to happen.
This is it. This is what happens.
Fantastic.
So, Mitch, just as a final thought, in fact, you touched on it earlier, but a couple of weeks ago, we were talking with our friend Harriet. We all said to each other, what do we think's going to have happened in space in 50 years' time? Mitch, you mentioned that you think that there's going to be, people living in space, and you think that there's going to be babies born in space. Can you create a picture of what your company will be doing in 50 years' time that you hope?
Well, in 50 years' time, all going well, I'll just about be retiring. So hopefully, in about 50 years' time, I would quite like there to be sort of mining colonies on places like Ceres, Eros, and sort of I think that sort of the mining companies will be sort of the early colonisers of sort of the asteroid belt, because there's the economic imperative is with them to do it rather than sort of going for any other reason. But in 50 years' time, I believe that sort of we'll have over 1 million people living in the moon, a couple of 100,000 living in Mars, maybe sort of tens of thousands dotted about various research stations throughout sort of the asteroid belt. I believe sort of in 50 years' time that human exploration of the inner solar system will be complete. Maybe sort of Saturn and Jupiter will have been explored by sort of humanity, but places like Pluto, Neptune, Uranus, they're a bit too distant. But you never know, there might be sort of some major change in sort of transportation technology and sort of propulsion technology in the next sort of 50 years that would make these more distant places accessible. But I just believe in 50 years' time, with all going well, by about the time I retire, I'd quite like there to be mining colonies with maybe just a nice wee statue of me in.
That's an incredible image. And where will your retirement home be, Mitch? Which asteroid or planet are you going to pick?
I would probably go for Ceres, just because it's the biggest one, and it would have the most gravity, so it would be probably the most livable asteroid of them all. But
nice.
It's one of them. It's going forward into the future. It would be probably a very nice place to be. I don't particularly want to die in this planet. I'd quite like to die somewhere distant and remote. So that would be a nice place to be if my retirement home was on an asteroid. I could get used to that.
When the first asteroids that are going to be mined, are they going to be near Earth asteroids or asteroids in the asteroid belt?
They are indeed going to be near Earth asteroids, because essentially they are the low-hanging fruit of the solar system. So they're just kind of within a few sort of lunar units of the Earth. So that would make sense to go to them first, because some of them are easier to get to from sort of an energetic point of view than the moon, because they don't have a gravity well. So you can go extract material and return to Earth without having to go in and out of the lunar gravity well. So near-Earth asteroids are an initial focus, and that's what the Asteroid Prospecting Satellite 1 is only focused on near-Earth asteroids. But going forward over the next sort of 30, 40, 50 years, we will look to be expanding into sort of the main belt asteroids as well, because there's 4 million of them that we know of, whereas there's only 10,000 near-Earth asteroids. So if we want to continue aggressively expanding as a company, we have to look towards sort of outward expansion. And then in 100 years' time, 200 years' time, who knows, we might be mining the Oort cloud and be sort of hundreds of astronomical units from Earth. But that's the more science fiction side of things.
Is there a near Earth asteroid that has a name that would be everyone rushing off to first? Is there one that's been identified?
I believe Ammon is the one. I don't know the number off the top of my head, but Ammon is my particular favourite, because that's the one where we did the calculations and we found that it would contain 100,000 tonnes of platinum and 10,000 tonnes of gold. So I think that seems to be the one that will probably get the most interest in the early days. But I mean, we don't even know the composition of most of these asteroids yet, so there could be even more sort of valuable resources to be found within sort of relatively close distances to the Earth. So this is why we have to prospect the asteroids now.
If there's any branding that can go on that mining drill, then, the Interplanetary Podcast is well up for being a sponsor.
Oh yeah, I'm sure we could arrange something with that.
We'll work out a deal.
That sounds good to me.
Awesome.
But whereabouts are you calling from, by the way?
Currently Motherwell, which, believe it or not, is an old mining town, which I find quite ironic.
Oh, that's fantastic.
So it's a former mining town that is now sort of getting into the new mining industry, which I find amazing. A phoenix from the ashes, but we should be moving over to Edinburgh in the next couple of months, and then it just makes things easier for us to centralise in facilities in Edinburgh. So somewhere in sort of central Scotland anyway.
Incredible stuff. Well, thank you so much for joining us, and that's been a super interesting conversation that I've been looking forward to. So we'd love to get you back on, we'd love to get you back on maybe in a year's time and see how things have progressed.
That'd be great.
Cheers, Mitch. Take care.
Take care.
Bye.
Cheers. Bye.
Cheers. Bye.
How incredible was that?
It was fantastic. I actually really did enjoy that chat. I really enjoy the fact that this could be a very, very brilliant moment. If indeed in 5 years' time there really is a new gold rush to the asteroids, that is what's going to open up space, isn't it? Asteroid mining.
I think I'm going to win the bet that me, you and Harriet had.
Ooh.
I think
and did
I'm
you? By the way, did you listen back and find out that it was 10 years and not 50 years?
Yeah, I concede.
I actually cut out that bit of the argument during the
Did you?
During the interview, because I thought it was too. I didn't think the listeners would like to hear us bickering.
People don't need to hear
us bickering like a married couple.
Oh dear me.
Anyway, during that interview, there was a lot of talk about British space laws. Well, so the Space Industry Bill will enable the first commercial space launches from UK soil in history, and will also take advantage of future developments like hypersonic flight and high-speed point-to-point transport. Ooh. So we might see a BFR landing in Britain soon.
Come on.
And that creates a potential for hundreds of highly skilled jobs, bringing in billions of pounds for the economy. And it's considered one of the most modern pieces of space industry legislation anywhere in the world.
That is exciting.
Yeah.
Matt,
so,
would you go out on a limb and say that I am probably the most highly skilled person you know?
Yeah.
I mean, I don't want to put words in your mouth.
I think now Stevens died. I think that's fair to say. Well, and Jim Bowen, of course.
Very similar people. Rest in peace, both of you.
So, Britain, often we're overlooked, but 1 in 4 telecom sats are built here. Do you know that?
Didn't know that.
Yeah, and so we've got a 6.5% share of the space sector, and that hopefully will be 10% by 2030. So this is That's what good. Joe Johnson, brother of of our famous Boris Johnson,
yes,
who's having probably quite a stressful time at the moment, to be fair. He said the space industry bill gives companies the ability to launch satellites from UK soil, putting us at the forefront of the new space race and helping us to compete as the destination of choice for satellite companies worldwide.
Here. Tip of the cap.
So something else hilarious in this week's news.
Oh, I know what you're going to say.
Go on in.
You're going to talk about Trump, aren't you?
I am going to talk about a bit of Trump.
What was the Space Force all about?
Space Force. I like it.
Do you think he watched an episode of Battlestar Galactica and then just decided to make a speech?
Yeah, or maybe listen to Brian May's Starfleet album.
Believe me, we have the best Space Force in the world.
Or maybe he watched Starship Troopers.
He could have done. Yeah, that's more likely.
I won't talk too much about that because I'm talking to David Baker this afternoon for next week's podcast for our...
He can give us the lowdown.
Our monthly catch-up, and Space Force is on the agenda for that little chat. So I can't wait to hear what David says about that, because he knows a lot of these people involved in all the kind of military aspects of space. There was one news article that I caught my eye. So this is the last one before we
go on.
Witter off. Is this week there was a company called Effective Space, which is a UK company, and they've got a contract of intent to launch a couple of drone satellites on a Proton rocket, a Russian rocket by ILS. These little drone spacecraft, they fly up to satellites that are wearing out. So you've got these multi-million-dollar satellites up in geostationary orbit, and their fuel's running out and stuff like that. So these drone satellites go up, hook themselves on with this patented technology, and actually do all the flying around for them, all the station keeping for them, thrusting around and making sure they stay in place. So it extends the life of these very, very, very expensive satellites. Genius.
How ace is that?
Yeah, it's going up on one of our favourites. It will be the space tug Breeze M.
Still funny. It's still funny.
And it'll be going up 2020, hopefully. So there's another little British space event.
Matt, I'd like to thank you. Could you tell us where you are? You're in a car, covered in snow.
Covered in snow, in the middle of Croydon.
I'm not going to lie, Matt. I'm a little bit worried about you getting out.
I'm actually freezing cold right now. But I wonder how good this is going to sound. But
I think you should put the engine on, and I think you should, heat the windows up.
Yeah.
I hope that you've got enough fuel, Matt, and I hope you've got a shovel in the boot.
Mm-hmm.
Can you please keep me up to date with your escape from Croydon, as I now call it?
The escape from Croydon. I'll take a picture of myself when I get home.
I think you should do a selfie for the blog.
Are you? And I suppose you're lying on your bed all in the warm.
I am actually.
Oh, you're so...
I'm lying on my bed in the warm.
Such a
I might go and get a little hot chocolate.
Yeah, such a hard life, innit?
It's tough
for Mr. Franklin.
It's tough for me. Matt, can I ask you a question before we go?
Yeah,
if I really like the Interplanetary podcast,
which you do,
it's not only entertaining. I'd quite like to do more. What can I do?
Well, you can go over to www.interplanetary.org.uk.
Right.
And there's various options for you there, because you could whiz over to iTunes and subscribe and leave a lovely review. And don't forget, there's a continual competition running that if you leave us an amazing review and then email through your details on the website, I'll send you out a mug if we think your review is great enough.
On.
But then, what else? What else can you do?
Well, I'll tell you what, Matt. If you want to comment on the show and tell us something you think that should be in the next episode, but I'll tell you what else you can do, Matt. And this is really exciting. Have you ever heard of Patreon?
Ooh, what's this? What is this Patreon, Jamie?
Well, if you enjoy this free show, you can only donate.
You can become a patron.
And the more you donate, the more goodies come with it. And by goodies, I don't just mean sick merch. I mean how engaged you are in the show. You could help us write the show.
Unbelievable.
It's big scenes, Matt.
It is pretty massive scenes. And of course, we do actually have some amazing patrons already. There's 30 of you out there helping this podcast. Some of you are at Daedalus level, which is executive producer. Okay, well, good talking to you, Jamie. Thanks very much for joining us, listeners. See you soon. Bye, Podcats.
Thank you, guys.
Bye-bye.
Bye-bye.